evening, class. Now, before we start, let us look at the assignment given to you last time. And what is the question, please? Can someone stand up and read the question for us? What is the question?
In the diagram,
A, B, C, D. A, B.
C, D, E, F.
E, F is a triangular prism, okay?
Angle ABC equals to angle DEF, which equals to
Therefore, please, angle 90 degrees.
AB equals to 24 centimeters.
AB equals 24 centimeters.
BC equals to 7 centimeters.
BC equals 7 centimeters.
CD equals to 40 centimeters.
CD equals 40 centimeters.
Calculate A, line AC.
Okay.
Then B, the total surface area of the prism.
Okay, now look at the diagram. We have this as right angle. This is A, B, C. This is a prism. E, F, G. This is 7 centimeters and this is 24 centimeters. We have this as 40 centimeters. Now the first question here is to calculate AC. Look at this. This is in triangle ABC. That triangle is a right angle triangle. And for us now to find AC, we are going to use Pythagoras rule. And that Pythagoras rule states that the square on the longest side, which is the hypotenuse, equals sum of the squares on the remaining two other sides. So it means that for us to get AC, which is the hypotenuse, AC square equals 24 square plus 7 square. So what is that 24 square? 576 plus what is 749? Addition of the two is what? 625. That is AC square. Now AC is equals to square root of 625, and that is what? 25 centimeters. That is AC. Now, but for us to find the total surface area of this prism, this is a prism, and to find the total surface area, at times I can open it for you now to see the net of this shape. This ABC is here. We have this as ABC, A, B, C. So we have a rectangle here. This length is 7. This is 24. Our AC that we have here is 25. AC is 25. We have a rectangle here. Now, the length of this rectangle will be the length of that prism. This is the length, 40 centimeters. We have this also as 40 centimeters. This is 40 centimeters. And this one too is 40 centimeters. 40 centimeters. 40 centimeters, 40 centimeters. Now, to find the total surface area of this prism, you must know that apart from these three rectangles that we have, 1, 2, 3, we have two triangles. There is one at the bottom, while there's another one at the top. That is why it is called a closed prism. So to find the total surface area, it depends on how you want to do that. I can use X, Y, Z to represent the rectangle that we have there. Likewise, let me use W to represent that triangle. Now let me first find area of triangle. Area of triangle. In this case now, there's no need to use Hero's formula to find the area of this triangle. It is a right angle triangle. I can use half base times height. This is half base times height. Then where that base is 7 and height is 24. Then what do we have? 2 here 1, 2 here 12. We have 84 centimeter square. So that is the area of triangle. Then area of X. Area of X is equals to, X is 24 times 40. You know, area of rectangle is length times breadth. So we have 40 times 24, or 24 times 40, 960 centimeter square. Then area of Y. Y is also 25 times 40, or 40 times 25, and that is what? 1000 centimeter square. Then area of Z. Area of Z is equals to, that is 7 times 40, or 40 times 7, and that is what? 280 centimeter square. Now to find total surface area of prison, is going to be addition of all these areas that we have. Area of X, area of X is 960, plus area of Y is 1000, plus area of Z is 280, plus 2 times area of triangle. Area of triangle is what? 84. Why is it that area of triangle is multiplied by 2? I've once explained that there is one at the bottom and there's another one at the top. So we have 960 all over 1000 plus 280 plus what is this? 168. Addition of everything is what? 2,408 centimeter square. So that is the total surface area of that prison. You know, if I want to find the volume of that prison, although that one is not part of the question, we are going to take it as AH, base area times perpendicular height. Where that base area is still 84 and perpendicular height is what? 40. You know, don't forget that that perpendicular height is also known as length. You know, when the thing stands vertically, you have height. But when it's placed then horizontally, that is what? Length. So length and height are the same. Is that taken? Now today, we are going to look at one important topic, and that is longitude and latitude. This longitude and latitude is still under mensuration. So we have the topic as latitude, and longitude. Latitude and longitude. Draw this diagram. The noise is too much. Now quickly draw this diagram. It is a circle that is drawn on the Earth's surface, having its center. A latitude is a circle that is drawn on the Earth's surface, having its center on the axis of the Earth. Having its center on the axis of the Earth. Full stop. Each of these lines, except the equator, which passes through the center of the Earth, Full stop. Then you draw this diagram too. Hello? Your noise is too much, please. Please, as you are drawing this, pay attention to this. You know, it is a fact that Earth is spherical in shape, but circle is a plane shape. So look at this. This is a model of a globe. This is a globe. And this globe that I'm holding here is not a circle, it's a sphere. And this is what we have here. This is the globe. But you cannot really see some of these features that we have inside this model here on the board. But I can still use it to explain. Let me start with North Pole. You know, we have North Pole, South Pole, East Pole, and West Pole. As we have it in bearing, 4 cardinal points. Although there's a polar axis, this line, look at the line. From the north to this is polar axis. And the line is here now. Look at the line. This is the line. This is the polar axis. The line that is drawn from here to this place is called polar axis. This is the line, polar axis. Okay, if you just hold a football, you can hardly see that feature there. You can hardly see that polar axis. Okay, so but this is the polar axis. Then apart from that polar axis, we have equator. Equator is a circle. Equator is a circle, but it is a circle that divides the globe into 2 equal parts. That is, this is hemisphere. You know, half of a sphere is hemisphere. This is hemisphere. This is another one. The two hemispheres will now give you a sphere. Now, if this equator happens to be half of this globe or half of this sphere, then it means that this equator is a great circle. I will still come back to that great circle, small circle. But look at this equator of the thing. This equator is called 0 degree. This equator is 0 degree. And when you have 0, 1, 2, 3, 4, 5, up to this point, it is the highest one you can have here is 90 degree. We have 0 degree, 1, 2, 3, 4, 5, up to 90. The highest one you can have here is 90 degree north. Okay. Then from here also, from here down, we have 90 degree south. Okay. Now it means that when you have 0 here, then you want to have 20 degree north. 20 degree north is somewhere here. 30 and so on, 40, 50, until when you now get to what? 90. Okay, 90 is called that 90 degree is north pole. 90 degree here is what? South pole. Then, and each one of them is a small circle. Why is it a small circle? Let me explain this. Look at this. This is a parallel of latitude. This equator too is a parallel of latitude, but it's a great circle. The reason why this equator is a great circle is because the radius of this equator is the radius of the Earth. You know that when you draw a circle, a line that is drawn from the center of a circle to any part of the circumference is called radius. Okay, now this equator that I'm holding here now, the center is here. You know, this is the center of the Earth. Then when you now draw a line from the center of the Earth to any part of the circumference, it's called big radius. There is difference between big R and small r. So this one is big R. That is why equator is a great circle. It's a parallel of latitude and it's a great circle. That is the only latitude that is a great circle. But when we now have other latitude, okay, like this one now, this is a latitude. Latitude degree north, latitude degree south. Now this one, radius of this one is not, radius of the Earth, because this is the center of this circle now. This is the center here. And what is the radius? It's the small r. That is why each one of them is a small circle except the equator. Am I communicating? That equator alone is a great circle because radius of that one is big R. While radius of other latitude is what? Small r. Is that understood? Now, so I've just explained parallel of latitude north and parallel of latitude south. Let me now come to this. Okay, I have explained center of the earth. Then I have explained polar axis. Then let me now come to this Greenwich meridian and meridian. You know, I said that equator is a circle that divides the globe into two equal parts. Likewise for that Greenwich meridian too. That Greenwich meridian is what? 0 degree, either 0 degree east or 0 degree west. I can call this equator 0 degree north or 0 degree south. If it is 0 degree north, 1, 2, 3, 4, up to 90. 0 degree south, up to 90 degree south. But Greenwich meridian is 0 degree east or 0 degree west. So it means that, look at this Greenwich meridian that I'm holding here. When you have it here, there's another one here. Okay, it's a circle now. So it means that if this one is Greenwich meridian, anything from here to this place is 180 degree east. And this one is 180 degree west. So that is why 180 plus 180 will give you sum of angles at a point, which is what? 360. Is that taken? Is that taken? So it is only when you have equator that it's okay, after holding this as equator, then this one is east and this one is west. Are you with me now? But when you look at the diagram, you'll be thinking that this one is east and this one is west. No, it is that Greenwich meridian that determines it. So if this one is, if I hold this one as Greenwich meridian now, this one is east, while this one is west. If I hold this one east and west, I hope that one is taken because the thing can be moving like this. Is that taken now? Then apart from this one, we also have another diagram because all these distance along the parallel of latitude, distance along the line of longitude depends on length of an arc. Okay, look at this thing now. Look at this right angle triangle that we have on the board. This is the right angle triangle I'm talking about. Look at this. This is the right angle triangle. This is the right angle triangle. And when you have a right angle, this one is small r. Why this one is bigger? Because this one has a connection with what? Center of the head. This one is bigger. That's why we have bigger. Why this one is what? Small r. Then this is the angle. This is the latitude. This place is latitude. Then for you now to, because I'm trying to derive the formula that one can use to find the distance along the parallel of latitude. Latitude is a small circle. So for me now to find the distance along the parallel of latitude, we are going to use, this is opposite, no, adjacent hypotenuse. And when you have adjacent hypotenuse, that is cos. It is cos. Cos alpha is equal to adjacent r hypotenuse bigger. When you cross multiply, we have bigger cos alpha. Small r equals to bigger cos alpha. So this is the formula for finding distance along the parallel of latitude. But this big R here is the radius of the earth, and that one is constant. It will be given to you as 6,400 kilometers. It depends on the question. Then R is radius of the parallel of latitude. Small r is radius of the parallel of latitude. Big R is the radius of the earth, while that alpha is the latitude itself. Because if I ask you to find this radius of latitude 20 degrees south, what we get there will be different from radius of latitude 50 degrees south. Are you with me now? You know, looking at the diagram like this, when you have this, radius of this one is different from radius of this one. So that is why we are going to have different radii there. Is that taken? Okay, now let us try this example. Are you ready? Calculate the radius of the parallel of latitude. Calculate the radius of the parallel of latitude 36 degrees south. Calculate the radius of the parallel of latitude 36 degrees south. Given that big R equals 6,400 kilometers. Given that big R equals to 6,400 kilometers. Full stop. Given that big R equals to 6,400 kilometers. Full stop. Formula. I've just given you that formula as big R, small r equals to, the formula is big R equals, small r equals to big R cos alpha. R is constant. That is 6,400 kilometers. I did not put any pole there. So to find the radius now, it's going to be big R is constant, 6,400, while that alpha is what? 36 degrees. And when you are pressing this thing, make sure you have your calculator in degree, not in rad. If your calculator is not in degree and you press cos 36, your value will be what? Will be wrong, because you are looking for you are looking for a value in degree and not in radian. So we now have this. What is that cos 36 in degree? 8090. Okay, please multiply 6,400 by 0.8090. 5,708. That is 71 kilometer. 5,177.71 kilometer. That unit is very important. Please, if you fail to put that unit, that is -1. Because this is mensuration question. You must put that unit, kilometer. Is that taken? And if there is degree of accuracy in the question, please make sure you round it up to that degree of accuracy. Is that taken? Okay. Are you good to go?
Yes, sir.
Okay, the second example. A geographical globe. The second example. A geographical globe has a radius of 18 centimeters. A geographical globe has a radius of 18 centimeters. Full stop. A geographical globe has a radius of 18 centimeters. Full stop. Find the radius of the circle formed. Find the radius of the circle formed by the parallel of latitude. Find the radius of the circle formed by the parallel of latitude. 56 degree north. 56 degree north. Full stop. Now look at this question. When you have a geographical globe, that is a sphere, and we have a geographical globe has a radius of 18 centimeters. That is bigger drawing. You know, it is possible for us to have all the structures that we have on this line just on the paper. Are you with me now? Just on the paper. Are you with me now? That is what is called scale drawing. So when you now have it as a geographical globe has a radius of 18 centimeters, that big R is 18. Big R is not 6,400 kilometers, but what? 18. So you can always have this type of question in object, because if you go ahead and use 6,400, you never get the answer. What is given as big R is 18, and your answer will also be in centimeter and not in kilometer. Is that taken? So we have big R as 18, and we have alpha as what? 56 degrees. Please quickly find the radius of that. But your answer will be in centimeter. Please help me to find the radius of that question. 10.1 centimeter or 10.07. Since there is no degree of accuracy in the question, please do that. And let me have your own answer too. 10.1 centimeter. Please don't forget to put that unit. That unit too is very, very important. You must put that here. Is that taken? Okay, so that is how to do about the second one. I hope it is clear.
Yes, sir.
Please, if there is any problem, feel free to ask a question. Feel free to ask question. Now, this is another question. On a globe of radius 60 centimeter, comma. What is that 60 centimeter? Bigger. Good. Bigger. Comma. Find the length in centimeter. Find the length in centimeter of the parallel of latitude. Find the length in centimeter of the parallel of latitude. 67 degree north. 67 degree north. Now, my question is this. What are we trying to find in that question? If you know it, please raise up your small arm. Is it small arm? Okay, what is your own? Diameter. Is it diameter? No. Circumference of the circle. Good. Please clap for him. And, okay, what is the formula for that circumference? 2 pi r. Now let me go back to the question and use that to explain. On a globe of radius 60 centimeters, that is bigger. Find the length in centimeter of the parallel of latitude. That latitude is a circle. And for you now, you know that in geography, if I want to find the distance of maybe railway, you know railway is not always a straight something. They will be using thread. They will use thread to measure the something and later place it on the ruler, right? Find the circumference. Because that latitude is a circumference. Am I communicating now? So the question is, find the length in centimeter, the parallel of latitude. That latitude itself is a circle, and for you now to find the length, it is what? Circumference of the circle. Now, if it is the circumference of the circle, so we can now add the formula as this. Length is equals to 2 pi r. You know, that's the formula. Length of circumference of the circle. That is the length. Abi? Now, but we already know that this small r is bigger cos alpha from the previous work there. Abi? Now, we can now do the substitution. 2 times, it depends on the question. If pi is 3.142, you use the 22/7. Let's use 3.142. Where this big R is what? According to the question, we have 60 centimeters. And what is alpha? 67 degrees. So we have 2 times, okay, what is cos 67? 0.3907. Multiply everything together. 147.31, or is it 31 or 32? 32 centimeter. Please always remember to put that unit. It is very, very important. Is that taken? Okay. This is the polar axis. This is the equator. We have 68 degrees what? 68 degrees south. If you pick a point on this latitude, 68 degrees, and you join this to the polar axis, that is radius. That is the radius. You got it right, but you just mentioned r, but it's radius. It's not distance. You know, we have distance between 2 points. And what is the formula? Distance between 2 points. Is it not square root s2 minus s1 square plus y2 minus y1 square? But we are not using that distance. And 3,4. Abi, am I communicating? Am I communicating? What I'm saying is this. You know, you can use, when you have something like 1,3 and 4,5, and you want to find distance between 2 points. That is where you can say, okay, distance is equal to square root of, distance is equal to, distance from the center of the circle to any part of the circumference. And in the question we have 6,400 kilometers. Y alpha is what? 68 degrees. Please calculate that. Calculate that. Please calculate that. 397.5. So that is how to find radius of the parallel of latitude. That is how to find radius of the parallel of latitude along small circles. Distances along small circles. Distances along small circles. Let S be the distance between 2 points on the same parallel of latitude, full stop. Since a parallel of latitude is a small circle, comma, since a parallel of latitude is a small circle, comma, x is equals to s is equals to theta over 360 times 2 pi r. Then r equals to big R cos alpha. Here R equals to, you can see that I'm still using, we have, this is a point. Let me take this as another point. The two of them, they are on the same latitude. The two of them are on the same latitude. If I want to find the distance, you know, I've first explained how to find the length of an arc. Because what you are going to use it, this formula is for length of an arc. Theta over 360 times circumference of the circle. Now look at this. This is the radius. This is another radius. Okay, look at this. This is length of an arc. So, and because this thing is a small circle, latitude is a small circle, that is why we have times 2 pi small r. Where that small r is big R cos alpha. But in a situation where you have a point here and you have another one here, the two of them are on the same longitude. And that longitude is a great circle. Okay, let me use this to explain. Let's assume that this is an orange. And you want to cut an orange. You know, if you cut it into 2 equal parts, that is equator. If you cut it here in such a way that the other part is bigger than the first one, then this one is the latitude. Although the other one is the latitude also. And you people, I cannot call it equator, but it is just that, I mean, the two of them are not of the same shape, of the same size. Are you with me now? So if you have a point here, and you have another one here, this is a great circle. If you just place your knife on the orange like this, you will always pass through the center. I'm not saying that you should cut an orange like this. You know, there is a place called stalk, Abi, on here. So if you place your knife on it, and you cut it, we always pass through the center. That is why each longitude is a great circle. Am I communicating? So this one now, when you have a point here and you have another one here, this is a small circle. This is the distance along the parallel of latitude. Okay? So this small r is known as big R cos alpha, but this theta is called angular difference. That is what I want to explain. When you have angular difference, that does not mean that you are going to subtract to get the angular difference. At times you can add to get the angular difference. What I mean by that angular difference is that if you have a point here, if this one is 20 degree west, if this one is 20 degree west, and you have another one 20 degree east. So for you now to get the angular difference, it's going to be what? Addition. It's going to be addition. Because it's like you have a point here. Look at this thing. Let me use this board to explain. This is the equator. You have a point here, you have another one here. This is a latitude. There's a point A and there's another point B. So this is the center of this, because every latitude must have its own center. This is the center of the latitude. We have a radius here, we have another radius here. And this is the length of an arc that I'm talking about here. So from here, let's assume that there are two students here. The two of them stand on this point. One move forward by 20 kilometers. Another one move backward by 20 kilometers. The two, if I don't want to find the distance between the two of them, is 40. Because here, at this point now, distance between the two of them is what? 0. Abi? But the moment this one move forward, and this one still remain here, distance between the two is 20. If this one also move backward by 20, the total distance between the two of them is what? 40. That is why, if you want to find, because some teachers always use this method that if the two of them fall on the same pole, subtraction. If the two lie on different poles, addition. That is what I have just explained. That if this one move forward, this one move backward, that is different position and different direction. And that is 40. But if this one move forward by 20, and this one also move forward by 15, angular difference is 5. You can see that if this one is the same poles, subtraction, different poles, addition. But I don't want you to cram the knowledge of, the idea of saying different poles, addition, the same poles, subtraction. You must know the reason behind this thing. And that is what I've just explained. Is that taken? So that is how to get the angular difference. Is that taken? Now let us now try this example. It's 40 degree north. You know, this is 0 degree, north is above, 40 degree north. Then you don't need to measure it though. Just know that it is above that 0, 40 degree north. 20 degree west, this is west here. You draw west here. This is 20 degree west. Please, I always use this method of labeling latitude. Because some teacher will just label it like this. It's okay, 20 degree west. But I'm trying to separate that of latitude from longitude. You can see, this is my latitude. Why this one is what? Longitude. There is no way you can add latitude to longitude. Okay, you can only add latitude to latitude or add longitude to longitude. You can never add longitude to 40 degree. There's nothing like that. Okay. Now with this, When this one is 40 degree north and this one is 20 degree west, there is a point of intersection. That's the point of intersection. The point of intersection is here. This is a latitude, this is a latitude and this is a longitude. This is the point of intersection. But don't forget that as we have one point of intersection here, there's another one at the back. Okay? There's another one at the back. We have one here, we have one here. Because this thing is a circle. And that longitude is also a circle. So there's one point of intersection here, there's another one here in this diagram. So this one is, like I said, this is point P. This is point P. Then I will now move on to the second point, which is 40 degree north, 10 degree east. This is east, 10 degree east. 10 degree east, I will label it as 10 degree east. And this one is what? Q. Is there any question on that? There's no question? Okay. So with this, don't forget that this latitude 2 has its own center. The center is here. So I will join that center to P and join this one to Q. This is small r. Abi? And this one too is what? Small r. What do we have? Length of an arc. That is why we have been using theta over 360 times 2 pi small r. So I will now state the formula. Length of arc or distance PQ, distance PQ equals to theta over 360 times 2 pi small. Do you know the reason why we use small r there? Why? What is the reason? It's a small circle. Because it's a small circle. So if that r is a small circle, if that latitude is a small circle, let us first get the angular difference. Now, I want to get the angular difference. This is how to do that. Look at P and Q. My two fingers are here now. Look at this. To get the angular difference, this is it. These are the two values we are going to use to get the angular difference. You know, I cannot move like this to get the angular difference. I'm talking about the angle. You know, when you have something like this, there's no angle between the two. The moment you have this, you have angle. Are you with me now? So we are using these two to find the angular difference. And don't forget the method that I explained earlier, that if this one is west and this one is east, it's going to be what? Addition. The reason is this. This one move forward by 10. This one move backward by 20. What do you think will be the distance? That is 20 plus 10. That is angular difference. So angular difference is 20 plus 10, and that is 30 degrees. Is that taken? Okay, so if it is 30 degrees, then I will now find them. What is alpha in the question? Alpha in the question is what? Alpha in the question. That is the common latitude. Look at this diagram now. This is latitude. There is a point here. There's another point here. The two of them, 40 degree north, 40 degree north. That is the alpha. You know, for this one alone, I can find the radius of this. I can find the radius of this one is big R plus alpha. Where alpha is what? 40 degree. I cannot use this one as alpha. Are you with me now? So this is alpha. So alpha here is what? 40 degree. And you can see how this question in word form. There are 2 points, P and Q, on the same latitude, 40 degree north. Their longitudes are 20 degree west and 10 degree east. So we are still saying the same thing. Is that taken out? So if you have it in word form, that is how to interpret it. So alpha now is 40 degree. Alpha is 40 degree. So there's no need to put north. Okay? Then we now find the distance. The distance now is going to be, let me state the formula again. The formula from there is distance PQ equals to theta over 360 times 2 pi small r, which is big R cos alpha. You know, I've changed that small r to big R cos alpha. Then you now do the substitution. What is angular difference there? 30 over 360 times 2 times what is pi? According to the question, 3.142 times 6,400 times cos, what is alpha? 40 degrees. Is that taken? Okay. Now, we now have this. 30 times 2 times 3.142 times 6,400 times, what is cos 40? 0.0 0.7660 all over 360. Multiply and divide by 360. 2,500.4 what? 41. Okay, if it is 41, 4 what? 37. Okay, 4137. 0.37. Okay, if it is 0.37, we have degree of accuracy in that question as 3 significant figures, right? Yes. What do you think will be the answer? 1, 2, 3. 257. 257. 0. You must add 0 to it. Because it's like you want to approximate 2,567.37 kobo. You now approximate it as 257. 257 is far from 2,000 and something. So, but when you say 2,570, very close to 2,567, so kilometer. Is that taken? Yes. Now write it down and then quickly try the second one. Okay, I can call on any one of you to come and solve the second one on the board. Just get prepared. I will give you a few minutes to work this. Hey, please, decorum. Hello. Cos 18. What's the value? 0.9511. Okay, all over 360. Please help us to multiply and divide the result. 4674 point what? 9 kilometer. Now approximate your answer to 3 significant figures. Is it the final answer? Yes. Hello. Did you praise it as 44 times 2 times 3.142 times 6 and 4 plus 18? No. You must first get the value of this. By 360. Is this the answer? No. What is the answer? 467. You are the one telling now what to write there now. 0.117 kilometer. Okay. Kilometer, right? Kilometer here. Okay, now answer will now become 4680 kilometer. Is this the final answer now? Yes, sir. Please clap for her. Clap for her very well. Please, look up, everybody, look up. This is T and this is S. If you have T and S on the equator, the formula will now change to 2 pi big R without cos alpha. Because that equator is a great circle. That's the only thing. So we have change this one to T and then change this one to S. It is not here. Is that it? That's the only thing. Although if I want to mark it to the I will condone that because it won't affect the final answer. But that diagram, that's not where you're supposed to place it. Is that taken? Yes, sir. Okay. So that is that. I hope there's no question on it. You have
any radius, like small r, like the first one we did first.
Small r. We have small r here in the diagram. This is small r. Look at this. This is T here. Join T to the center here. We have small r. Join this one to the center. We have small r. This is small r. This is small r. It's like we have the diagram as this. Small r, where the angle is 44. That is small r. Is that taken? Yes, sir. Okay. Now another question. 77 degree north. Two places are on the parallel of latitude 77 degree north. Full stop. Their longitudes are 154 degree east and 142 degree west. Their longitudes are 154 degree east and 142 degree west. Measured along the parallel of latitude. Find their distance apart, measured along the parallel of latitude. Now let me explain this question. There is something I want to explain here. Because when you have 154 degree east and 142 degree west, please, 7 degree north, okay?
Their longitudes are 164 degree east and 142.
164 degree east, I'm coming. 164 degree east. 154 degree east.
And 142.
Okay, wait, this is the first point. And what again?
142 degree west.
142 degree west. 142 degree west. You know, this was supposed to be the point of intersection of the two lines, Abby. But I don't want to put it here. I want to put it here. Why? Addition of the two is more than 180. What I'm saying is this. Look at this. When you have a circle, if this one is a point, and this one is also a point, once you have them on the same straight line, that is 180. If the angular difference is, please let me add, 296 or so. 296, Abby? Abby? So it will now be here, and not here, and not somewhere here. It will be at the back. What I'm saying is this. And the thing is more than 180. Where you're supposed to have it on a straight line like this, you now have it somewhere here. Are you with me now? Okay. So it means that we are going to have the diagram as this. Now that the angular difference is 296, there is what is called, you know, if I want to move from here to this place, then this one happens to be the shorter distance now. Yes. So we are looking for that shorter distance, not long distance. And that's why we are going to say angular difference is 360 minus addition of 142 plus 154. Is that taken? Yes, sir. So this one will now give us 360 minus 296, and that is what? 64 degrees. So angular difference is 64. Please, if the sum of two angles there is more than 180, you must subtract it from 360. That is what is called shorter distance. Although we are still going to find there is what is called shorter distance and shortest distance. Shortest distance on the parallel of latitude is always a gray circle. It's always a gray circle. So when we get there, I will explain them better. So this is the angular difference. And for us now to find distance, let me use the other side then. This one is bigger cos alpha. So what is my theta there? 64. Okay? All over 360. Maybe you change that. We are not given pi in that question, Abi. I can use pi equals 22 over 7, 77. That is the common latitude. So we now have this. 2 times 22 over 7 times 6,400. What is alpha? 77. Please let me calculate this. But listen, if you want to calculate this one, 64 times 2 times 22 times 6,400 times cos 77 is 0 point something. Please don't press it directly. Because if you press it directly, you are saying that you want to use all the values of that cos 77, you know, because if you have 0.77 whatever, then you use it to multiply. It will affect the answer. You know, if you are using 4-figure table, we have 4 numbers after the decimal points. So that's why we advise you not to use everything that you have on the calculator to calculate it. So why this one is all over 2520. 360 times 7 is what? 2520. Please calculate that for me and let me. 1609. 1609. Point what? Point what? 0.14 kilometers. There is no degree of accuracy in that question, so you can leave it as 1609.14. Or if you want to approximate it, you state it there. Maybe to 2 significant figure or to 3 and so on and so forth. Don't worry. Hello. Label your diagram. North, south, east, west. 0 degree. East. Okay. Locate your point A. provide a noise now. Please give us that. Hello, hello. 95 degree what? Okay, we are still going to find. Okay, yeah, continue. Hello. 54. Is it 54 degree west or 54 degree east? Is it east or west? It's west. Okay, now please let me quickly add one or two things to this. You have done well. Please clap for her. Now, is it 77?
Yes. Degree west. Yes.
Beta is 18. Beta is 18. And what is that? 77 degree west. Okay. But look at this. Let me quickly add this to it. Equator, 0 degree east, 0 degree west. We have 41 degree north. 41 degree north. We have 18 degrees. 18 degrees. This is point A. Now the question, B is due west of A, Abi? B is due west of A. You need to locate that. This is B. Due west of B does not mean that it has crossed over to that west pole. My answer will tell me the correct one. So this one is, let's say beta. This is point B. And call it, let us call it beta. I mean the longitude. The distance is 8,000. Okay. So my angular difference is, according to my own diagram, because this is beta degree east. According to my own diagram, angular difference is 18 minus beta. Because the way it is drawn now, 18 is more than beta. Abi? Am I communicating?
Yes, sir.
Okay. So, and what is alpha? Alpha is 41. I will now come here and write distance. Distance is 8,000 is equals to theta 18 minus beta all over 360 times 2 times 20 over 7 or 3.142. Okay, 3.142 times 6,400 plus 41. Cross multiply. 8,000 times 360 is equals to 18 minus beta. 2 times 2 times 3.142 times 6,400 times 0. What is cross 41? 0.7547. Okay, multiplying 2 times 3.142 times 6,400 for me. What about this? This one, Abi?
8,000 times 360
equals what?
2 million.
880,000. Something like this, right?
Yes, sir.
What about that one? 30,000. 33. 3352. 3352. Divide 2.2. 0.2. Where divide? $94.87. Okay. 89. 94.89. So take beta to this side. 18 minus 94.89. What do we have?
Minus 76.89.
Minus 76.89 degree. So if it is minus 76.89 degree, according to my diagram, it is east. Abi, degree west. Having that minus shows that it has crossed over to the next pole. So I have changed it to 77 degree west that we have 10. Is that taken out?
Yes.
Assignment. Find the distance apart. Find the distance apart, comma, measured along the parallel of latitude. Find the distance apart, measured along the parallel of latitude, comma, of two places which both have latitude, of two places which both have latitude 63 degree north and whose longitudes differ DIXSTR by 1 degree. Have enough values to draw the diagram. Number 2. Number 2. Havana, HAVANA, Havana and Canton are both on latitude 23 degree north. And their longitudes are 82.25 degree west, 82.25 degree west, and 113.25 degree east, and 113.25 degree east respectively, and 113.25 degree east respectively. Full stop. Find their distance apart. Measured along the parallel of latitude. Find their distance apart, measured along the parallel of latitude. Find their distance apart, measured along the parallel of latitude. Full stop. Good day.